Okay, now let's begin the coding part. And I have pre-written the code here because otherwise the video is going to be very long. But I encourage you to code along with me in order to understand the concepts much better. So here I have a function, the main function, which essentially takes the number of disks that we need to consider. So I've taken 4 here, and this is passed to the Tower of Hanoi function, which takes the parameters n, which is the number of disks. Then A is the source, B is the destination, and C is the auxiliary or the helper rod. And this is passed on to all these parameters, all these formal parameters over here. And the base case, as we discussed earlier, is that we are going to move the smallest disk from A to C, that's from the source to destination first, and that's the base case. So this is the step 1 that we are going to perform. Then after this, what we need to do is we have to move the 2 remaining disks or disk on A, that's the source, to the auxiliary rod via the 2 rods. So we have to move these two disks from A to B via the C rod over here. And then we are going to, since after this step we are going to have, basically it ends over here, and now we have the freedom to move the largest one from A to C. So we are going to move the largest one, that's represented by n. So that's basically the third rod from A to C, that's from the source to the destination via the auxiliary rod. And we are just going to print it out over here. So this is one of the steps, and then we are going to finally move all these rods which we have on the auxiliary to the destination using the source pole. So using the source pole, and that basically concludes the code over here. So the first part is we are going to move the smallest one from the source to the destination. Then after that, our goal is to move the 2 rods. So one of them is on the destination, one of them is on the source, to the auxiliary using the source rod. So here it's this step over here. And now after that we have to move the ones which are on the auxiliary to the destination. And before we do this, we have to print the step that the largest disk would in fact move from the source to the destination. And that's about it. Let me just run it over here. Yeah, so you can see that it gives all the steps for 4 disks, and yeah, that's it looks to be correct, and you can also dry run it. And that's all I have for this video, and I'm going to post a lot more algorithmic content in this channel, and stay tuned for that. Have a nice day.